Hi everyone, this is Miss G. Fill in your notes in section 5C as you watch this video. In this section, I am going to define what an electrochemical cell is and explain how it works. An electrochemical cell is a chemical system in which a redox reaction can occur. When electrons flow from the substance being oxidized to the substance being reduced, a current is then established. And if the reaction occurs spontaneously, this is called a voltaic or a galvanic cell. So why learn about electrochemical cells? Well, as you know, the problem driving this unit concerns mitigating the impact of batteries on our environment. It's useful to understand the chemistry behind the components and function of batteries in order to help us solve this problem. Keep in mind that a battery is very basically a way to convert stored chemical energy into useful electric energy. A battery is a device consisting of a galvanic cell or a series of combined galvanic cells that can be used to derive a direct electric current at a constant voltage. Self-contained batteries do differ a bit from the electrochemical cell I'm going to show you, but I'll talk about those differences later. In this electrochemical cell, you see two beakers. The beaker on the left-hand side contains an electrolyte, a 1 molar solution of zinc nitrate, and it also contains a piece of zinc. The wire attached to the zinc is attached to the negative pole or the black lead of a voltmeter. The beaker on the right contains a 1 molar solution of copper 2 nitrate and a piece of copper. The copper is connected via wire to the positive pole or the red lead of a voltmeter. The copper metal in the beaker on the right has a higher affinity for electrons than the zinc does. It's this difference in affinity for electrons that drives the electrochemical cell and creates this spontaneous current. In the left beaker at the anode, we have an oxidation taking place. Here, zinc metal oxidizes or loses electrons to form zinc plus 2 ions, which then become part of the solution. And as a consequence, this piece of zinc begins to lose mass. The electrons from the zinc travel through the wire, through the voltmeter, and finally to the cathode. The electrons from the cathode are picked up by the positive copper 2 ions that are part of this copper 2 nitrate solution. And then those copper 2 ions become copper atoms, which then plate onto the piece of copper metal. And the copper metal ends up getting heavier as the copper ions in this blue solution diminish. So actually over time, this blue solution ends up getting lighter and lighter. Let's fill in the definition of anode and cathode. The anode is the cell in which oxidation occurs, and the cathode is the cell in which reduction occurs. I'm going to talk about the salt bridge here, so you can stop this video to fill in the notes on this section as you need it. The purpose of this salt bridge is to maintain a charge balance or electrical neutrality within each of these cells. As the concentration of positive zinc ions starts to build up at the anode, something is needed to neutralize this charge. So the salt bridge in this galvanic cell contains a solution of potassium nitrate, which can diffuse through this porous material right here. Perhaps if this is a cotton ball at the ends of the bridge. Negatively charged nitrate ions end up diffusing into the zinc nitrate solution. So remember, this potassium nitrate is actually just nitrate ions and potassium ions freely flowing, and the nitrate ions can diffuse through that porous material, thus neutralizing the zinc ions as they're formed in that oxidation process. Similarly, positively charged potassium ions from the potassium nitrate diffuse into the cell on the right, neutralizing the nitrate ions that are left behind as the copper ions are reduced and plate onto the metal strip. A battery, such as a Duracell battery, differs from an electrochemical cell in that the battery is self-contained, and it doesn't need a salt bridge. Some of you will be studying this battery in greater detail and will explain to us later how it works. I wanted to talk to you briefly about what this voltmeter is measuring. Voltage is a difference in potential energy across 2 points, and more specifically, it's a change in potential energy per charge. So the unit of voltage is volts, and a volt is equal to 1 joule, which is a unit of energy, per coulomb, which is a unit of charge. So I'm going to give you an analogy to try to help you picture this. Imagine a hose that's attached to a water faucet. If you turn the faucet, then water flows from the high pressure area at the faucet to the low pressure area at the end of the hose. In this analogy, the flow of water is analogous to the flow of current, and then the areas of high and low water pressure are analogous to regions of high and low electric potential across the voltmeter. So the voltmeter in essence measures the potential difference across that voltmeter from the two half cells. So we can talk more about that in class when we discuss your questions. In the next video, I'm going to finish the notes for section 5C and show you how to write the electrochemical cell notation for a galvanic cell. And I'm also going to talk a little bit about how we use reference electrodes to determine something we call standard reduction potentials. That's it.
Made with Doodlecast Pro.